Today we're going to do lesson 2.6, solving absolute value inequalities. Now, this is going to look very, very familiar for the most part because in chapter 1 we solved absolute value equations. Now, I want you to think back for just a second to absolute value equations. How many equations were we required to write and solve? 2, all right? So, right underneath our essential question today, how can you solve an absolute value inequality? You see right away that we are going to once again be writing 2 inequalities. So take your highlighter and highlight for me inequality 1 and inequality 2. So just like we had to write 2 equations for absolute value equations, we're going to write 2 inequalities for absolute value inequalities. Now, just like equation number 1, inequality 1 simply requires us to remove the absolute value symbol and write down what we see. Inequality number 2 is almost identical to equation 2, but with one extra step. It says remove the absolute value symbol, change the sign of the answer. Remember, the answer was on the right side of the problem. And then we have to flip the inequality symbol. So this is the new piece. Instead of leaving the inequality symbol the same, we actually have to flip it in the second inequality. Now here's the other important piece of information, and I want you to highlight it. The final answer must be written in and or form. So that's new also. Our final answer is not going to be 2 separate inequalities boxed in. We have to either write it in the and form or the or form that we learned in yesterday's lesson. Now let's talk about this for just a second. How are we going to know? Because we're going to be writing 2 separate inequalities, working them out, solving them, and we're going to have 2 separate answers. How are we going to know if it's an and problem or an or problem? The variable being in the middle, though, is not going to happen, remember, right away. We're going to have to do that. So how are we going to know if the variable should be in the middle or not? What have we been doing with all of the solutions that we find? We graphed our solutions. We've been graphing our solutions all chapter. So we're going to take our 2 answers, and on the same number line, we're going to graph it. That way, we'll be able to tell if we're looking at an and problem or an or problem. Now, think back to yesterday. If it's an and problem, what's the graph going to be doing? They're going to meet in the middle. So if we graph our 2 solutions and the arrows or the lines meet in the middle, then we know it's an and problem. If it's an or problem, what's the graph going to be doing? Going in different directions. So we will not be able to write our final answer on these problems until we've graphed the solution. Now let's get right into example number 1. It says solve the inequality and graph the solution if possible. So I kept letter A pretty simple. Who is brave enough to tell us the very first inequality that we're going to write for letter A? All right, Hannah? There you go. Drop the bars, write what you see. X is less than or equal to 3 5/10. Now, is anybody even braver and want to try inequality number 2? All right, Matthew. All right, I like everything you did except one thing you forgot. You dropped the bars, you changed the sign of the answer, but what is that extra step? Look in your notes that you forgot that we had to add to this. You just forgot to flip the sign. So instead of less than, we flip it and it becomes greater than. Good. So drop the sign. Drop the bars, flip the sign, and change the sign of the answer. Now, this is what I want you to do. This is not optional. This is what I want you to do. I want you to leave yourself space before you draw your number line, because we want to come back and we want to put our final answer above the graph like we've been doing all chapter. So leave yourself some space, but we've got to graph this in order to figure out what kind of problem it is. So what number is going on the left side? The negative 3 5/10, and what number is going on the right? The positive 3 5/10. The circle, now be careful, the circle on negative 3.5, make sure you're looking at the right inequality, is supposed to be what? Closed, because it's or equal to. All right, very good. It's part of the solution. And the circle on 3.5 should be what? Closed. Also, because it's or equal to, it's part of the solution. Now, again, be careful. Make sure you're looking at the right inequality. What direction should the arrow be going from negative 3.5? To the right, it's greater than. And the inequality, or the arrow from the positive 3.5. To the left, because it's less than. So what do the arrows, or what do the graphs do? They meet in the middle. They intersect in the middle, which makes this what kind of a problem? An and problem. So when we go to write our final answer, how do we begin to write an and problem? You put the x, the variable, in the middle. So x, what number's going to the left? Remember, the smaller number goes to the left, larger number goes to the right. All right, and what number is going to go to the right? The positive 3.5. Now, this is where you got to be careful, okay? X is supposed to be what to negative 3.5? Greater. So when I put that symbol in, read from the variable. Does it still read the same? Read from the variable. Does it still say x is greater than or equal to negative 3.5? Okay, then we put the symbol in correctly. And x is supposed to be what to positive 3.5? Less than or equal to. So read from the variable. Does it still read the same? Yes. So I box in my final answer. All right, now look at letter B. Before we do anything with letter B, I want to take you back to equations again. Remember, we could not begin to write our equations until what was true about the absolute value part of the problem. It was isolated. So we're going to begin to ask ourselves that question. So looking at letter B, is the absolute value portion of this problem isolated? Okay, but here's the absolute value part. It's not about what's inside the bars, it's about what's outside. Is there anything outside those bars? No, there's nothing on the outside of those bars. So that absolute value portion is isolated. So what is the first inequality that we're going to write? 2w minus 1 is less than 11. Beautiful. Drop the bars, write what you see. All right, what about the second inequality? Very good. 2w minus 1 is greater than negative 11. You dropped the bars, you flipped the inequality symbol, and you changed the sign of the answer. Now, remember, don't call me after midnight is still in play, but hopefully you don't need all that, because what are we going to do first? We're going to add the 1. We got to get w by itself, so we're going to add the 1. And since the left side of both of these is exactly the same, we can work this problem at the same time if we'd like to. So the 1's cancel, and we have 2w is less than 12. Cancel here. 2w is greater than negative 10. All right, and how do we finish solving for w? Divide both sides by 2, and we do the same to both inequalities. 2 over 2 equals 1, so we cancel. We don't need to bring that down. And w is less than 6. The 2's cancel, and w is greater than negative 5. Now remember, that's not my final answer, so I'm not boxing anything yet. Leave yourself space, and let's graph. What number is going to the left? And to the right? 6. All right, let me hear more participation. What type of circle is going on negative 5? Open, because it's just greater than. And the circle on 6? Because it's just less than. So those numbers are not part of the solution. Now, my arrow, be careful, make sure you're looking at the right inequality. My arrow from negative 5 should be going what direction? Because it's greater than. And my arrow from the left? Left, because it's less than. So once again, what does my graph do? It intersects, it meets in the middle. So is this an and or an or problem? This is an and problem, so how do I begin to write my final answer? W in the middle. What number goes to the left? And what number goes to the right? 6. Now, W is what to negative 5? Greater than, so be very careful. You say, well, that looks like a less than. Not if I read from the W. If I read from the W, does it still say the same thing? Yes. And W is what to 6? Less than. So again, if I read from the W, does it still say the same thing? Yes. So now I box in my final answer. Now, moving right along to letter C. Is the absolute value portion of the problem isolated? Yeah. So we are ready to write our inequalities. But let me ask you this. Does anything about this problem jump out at you? The answer is a negative number. Now, if we go back to equations, when an absolute value was set equal to a negative number, what was our final answer? There was no solution. So let's stop and think if that will work for this type of problem. Okay, what numbers are less than negative 1? Give me an example of a number that is less than negative 1. Negative 2. Give me another one. Negative. Give me another one. Get creative. Negative 5,000, right? Is there any number less than negative 1 that is not a negative number? No. All numbers less than negative 1 are going to be negative. And can an absolute value ever have a negative answer? So what do you think the answer is? No solution. And you would be correct. So no solution. And then I want you to take your highlighter and I want you to highlight. Again, you've got to look for this. If you don't look for it, you'll miss it and you'll write 2 inequalities and you'll waste a whole lot of time. Now, we're going to add an extra note here. So somewhere around letter C, I want you to add this, okay? Any absolute value, and I'm just putting an X in there because it could be anything, any absolute value that is less than or equal to, because we're talking it could be less than symbol, it could be less than or equal to. But if it's less than or equal to 0 or a negative number. So we saw up here there was a negative number. But what happens if I put a 0 up there? What kind of numbers are less than 0? Negative numbers. So even if I were to throw a problem in and I put it was less than 0, the shortcut still works. It's still no solution. So any absolute value that is less than or equal to 0 or a negative number has no solution. So I want you to add this little extra note and then I want you to highlight it because this is important. Again, if you aren't looking for this, you will miss it and you'll do a whole lot of extra work. All right, now look at letter D. Is this problem ready for us to write our inequalities? No, why not? The absolute value is not isolated. Now, I also heard because there's a negative answer, but remember, we cannot make that call until the absolute value part is isolated. So we've got to get this piece isolated first. And how are we going to do that? We're going to add 3 to both sides. So the absolute value of n plus 2 is greater than or equal to, what's negative 6 plus 3? Negative 3. Now listen, don't get rid of the absolute value bars yet. Some of you are getting rid of the absolute value bars, and so you go right into writing 2 inequalities when you might not need to. All right, the absolute value of n plus 2 is greater than or equal to negative 3. Now that it's isolated, does anything jump out at you? We, again, have a negative answer, but guys, I want you to highlight this. Look at the symbol this time. Okay, this is what's trickier about inequalities. We can't automatically say that the answer is no solution just because the answer is negative. We have to look at the symbol. So let's talk about this. What numbers are greater than negative 3? Keep going. All positive numbers, right? All positive numbers are bigger than any negative number I could give you. So what do you think the answer is going to be for this type of problem? Hannah, what did you say? Okay. Think a little bit harder. There we go. It's all real numbers. So it's another shortcut. It's still a shortcut, but instead of having no solution, it means any number would work. So this one is all real numbers. So you have to be very, very careful. There are 2 separate shortcuts in these inequality problems. If your absolute value is less than 0 or a negative number, it's no solution. But here's your extra note. Any absolute value that is greater than or equal to 0 or a negative number, because again, what numbers are greater than 0? All positive numbers, right? So any absolute value that is greater than or equal to 0 or a negative number is all real numbers. So there's 2 separate shortcuts that you're looking for. You've got to pay attention to the symbol. It's all about the symbol. All right, that leads us to our very last example, letter E. Is this one ready for us to write our inequalities? No. Is this one ready for us to say no solution or all real numbers? No, because we have to get what by itself? The absolute value piece right here. Now, does it matter what I move and in what order I move it? Yes. All right, which number am I moving? Good. I have to move the 7 first because I have to add or subtract before I multiply or divide. So we're going to add 7 to both sides. And we have 3 times the absolute value of d plus 1 is greater than or equal to what? 6. Am I ready now? No. What do I still have to move? 3. How am I going to move it? Divide. You say, how do you know? Because 3 and that absolute value bar with nothing between them is what operation? Multiplication. So I have to move it with division because I cannot distribute over the wall. All right. So the 3's cancel. Again, do not get rid of the absolute value bars yet. The absolute value of d plus 1 is greater than or equal to what? 2. Now am I ready to write my 2 inequalities? Yes. What will the first one be? D plus 1 is greater than or equal to 2. And Maddox, what's the second one going to be?
D plus 1 is less than or equal to negative 2.
Beautiful. You drop the bars, you flip the sign, and you change the sign of the answer. How do we solve for D? Subtract 1 from both sides, and this will work in both inequalities. So D is greater than or equal to 1, and D is less than or equal to negative 3. Now, again, leave yourself space, all right? Drop down where you're going to do the graph underneath the inequalities. I'm going to go over here to the side, but let's graph it. What number is going to the left? And what number is going to the right? The circle on negative 3 and the circle on 1. Good. Both are or equal to, so both are part of the solution. Now, the arrow from negative 3. Good. D is less than negative 3. And the arrow from number 1. Because D is greater than or equal to 1. Now, from the graph, what do we know? What type of problem are we dealing with? This is an OR problem because the graph goes in different directions. Now, put your pencils down for just a second and let me have your attention. For those of you that don't like to do your work like I do it on the board, this is one of those instances where I would do the work like I do it. All right? Because some of you on your test last week, you tried to write your 2 equations on top of each other and smush all the work into this tiny little space. All right? With equations, not a huge deal. But I'm trying to save you time. Because if this is an OR problem and you have your 2 inequalities side by side like I do, what's the only thing you have to do to finish this problem? Just put an OR between your 2 inequalities and box in your answer. But if you are a hot mess and you have your 2 inequalities all over the place, now you've got to completely rewrite the final answer. All right? But we're setting up, so if it's an OR problem, all we got to do is stick the word OR in the middle. And that is lesson 2.6.